What else? What is the difference between boundary condition and initial condition? So boundary conditions are at the boundaries and initial conditions are basic conditions.
Particular only that.
Postgraduate students. Initial conditions. Initial conditions are at the start of the vibration. They are time dependent. Boundary conditions are displacement dependent, space dependent. Initial conditions are time dependent. Are you getting? If I say there is a cantilever beam,
when it is in rest, sir.
or I mean, he's asking something. Yes, what's your doubt?
When it is in rest condition, sir.
When it is in rest condition at t is equal to 0, right? Those are initial conditions. Boundary conditions here are at x is equal to 0, y is 0, and y dash, that is the slope. The derivative of y with respect to x, dy by dx is theta, that is 0. These are boundary conditions. They are x dependent, dependent on space. Same cantilever beam. It is vibrating at t is equal to 0. Its displacement is 0, y is 0. Or if you are giving some initial displacement, you can say y is y0. Like in this problem. At t is equal to 0, you have pulled this mass, still you are held it in position, still it is at rest at y0. And now you are releasing it. So at t is equal to 0, y is y0 is the initial condition. Clear these basic doubts. And फुकटात म्हणजे त्याला काय additional charges we are not paying. Only thing that paying your fees in tax. Big fees. But after you go from here, you should be at least an engineer who is having all fundamentals clear. Right? Okay. So these are space dependent. And these are time dependent. Okay? Okay. So A and B are the constants which depends on initial conditions. Now what are the initial conditions? There are two constants, so I should have two initial conditions to find out these constants. So first initial condition is at t is equal to 0. Y is y0. Maybe 1 centimeter, 2 centimeter, whatever initial displacement you are giving. What is the other initial condition? Velocity. How much it is? 0. Yes. I have pulled this mass, held it in position. It is at rest at y0, and therefore at t is equal to 0. Velocity, that is y dot, is 0. That's second initial condition. Now two initial conditions, two constants I can find out. Okay, now you can say substituting first initial conditions in equation 2, right? Substituting first initial condition in equation 2. So if I substitute p is equal to 0, I get y0 is equal to a, cos 0 is 1, and sin 0 is 0, so I get a is equal to y0. First constant I got. Well, next I have to substitute second initial condition, but before that I should know equation of y dot. How do you derive equation of y dot? Taking derivative of equation 2 with respect to time first. So say taking derivative of equation 2 with respect to time. You will get y dot is equal to what is derivative of cos alpha t minus sin alpha t. That's all. Alpha is also to be taken out. So it is minus a alpha sin alpha plus what will be derivative of sin alpha t? Alpha cos alpha. So 3 alpha cos alpha. And now you can say this equation 3, substituting second initial condition in equation 3. You will get that t is equal to 0, y dot is 0. So 0 is equal to this is 0 plus b equal, and that's why I get b is equal to 0. So I got value of b, I got value of a. And now you can substitute a and b in equation 2. Substituting values of a and b in equation 2. You will get y is equal to y0 cos alpha. Let's call this equation 4. So can you Muslim telecast चालू है? Are you able to see Mr. Gore?
Yes, sir.
Okay. You are from Solapur, no?
Yes, sir.
You are enjoying at home?
No, sir. I am at in SMC.
You are at?
SMC Corporation.
Acha, you are working in corporation.
Yes, sir. In Zone 2.
Okay, okay. And you are attending lecture from there.
Yes, sir.
That's really good. Fine, fine. No problem. Okay. So now I got the equation for y. Can I plot the graph? That is what expected. Plot the graph of displacement versus time. Let's plot. The equation suggests graph of displacement is graph of cos alpha or cos theta, and every ordinate of cos theta is multiplied by y0. So you just plot the graph of cos theta. Graph of cos theta is like this. Right. Cos 0 is 1. And that 1 is multiplied by y0. So here y0 plus minus plus minus. And the maximum amplitude is always y0. Here it is plus or minus. Yes. When cos theta is 0, cos 90 is 0, cos of pi by 2 is 0. So, when alpha t is equal to, I will say, n pi by 2, where n is 1, 2, 3, and so on. No, all odd numbers 1, 3, 5, and so on. So when I take n is equal to 1, t is equal to pi by 2 alpha. This is pi by 2 alpha. This time is cos theta is minus 1. So cos of 180, you can try on calculator. Cos of 180 is minus 1. Right? That means whenever alpha t is equal to n pi, where n is 1, 2, 4, 6, odd numbers. Sorry, even numbers except 1. So C will be here pi upon alpha. Cos theta 0 to 3 pi upon 2. This is 5 pi upon 2. This is 2 pi upon 3. This is 3. It's not 1, 2, 4. It is 1, 2, 3, 4, and so on. Right? Agree? Let us interpret this graph. Let me see physically what this graph shows. I have pulled the mass. It is at rest at y0. So at time t is equal to 0, displacement is y0. Is it right? The moment you release, it comes to neutral position. Displacement is reducing. It comes to neutral position. Then it goes to negative extreme, minus y0. Then again come to neutral position. And then again go to positive extreme. This is how, this is one cycle of operation. And then the cycle further repeat, keep on repeating infinitely. This is how physically you can interpret the graph. Okay? Now, if I ask you a question from this graph, can you tell me what is the period of vibration? Capital T. What is the definition of period of vibration? Time required to complete one cycle of vibration.
Y0.
Y0 is displacement. Initial displacement. Period is the time required to complete one cycle of vibration. So, this is the time. That is capital T. Time required to complete one cycle of vibration. So, from here I can get T is equal to 2 pi upon 8. Right? What is the relation between T and omega? See the very first lecture or second lecture where we have defined F omega T. T is equal to 2 pi upon omega. So we can say on basics T is equal to 2 pi upon omega. What is the conclusion? Omega is equal to alpha. The natural frequency of vibration, the natural circular frequency of vibration of a single degree of freedom system is given by alpha. So you can say, write these two equations first and then say, comparing above two equations, we can indicate omega is equal to alpha. And yesterday we had assumed alpha square is equal to k by m. So what is alpha? If alpha square is k by m, alpha is under root k by m. So that is equal to under root k upon m. So the most important conclusion I am getting, the natural frequency of vibration is given by under root stiffness upon mass k upon m. And whenever there is alpha, you can write omega, like y is equal to y0 cos omega t. So you can say the solution of differential equation, therefore, the solution of differential equation can be written as y is equal to a cos omega t plus b sin omega t in general. A cos omega t plus b sin omega t in general. Agree? So it's a very, very important conclusion. And similarly, now you can write equation of period also. T is equal to 2 pi upon omega. And if you reverse, then by k. So I got a simple equation for natural period of vibration also. Right? Okay. Well, what else is asked in this question? What else is asked in this question? But before that, what is the initial velocity? What is the initial velocity in this problem? Zero. You have pulled the mass, you have kept it at rest, and now releasing. Initial velocity is zero. Can you show me in this graph? In this graph, can you find velocity directly from this graph? If the basic fundamentals are clear, what is meant by velocity? You can tell me. Yes, from this graph also we can find velocity. Though this is a graph of displacement versus time, you can find velocity also. Velocity is y dot that is equal to dy by dt. What is dy by dt? What is dy by dx in general? What is dy by dx in general? Represent derivative. What is meant by derivative? What is meant by integration? What derivative gives you? What integration gives you? And unless it is clear, on आविष्कार derivative करते हो, क्या है integration आविष्कार करते हो, but what it is, you should understand. लेकिन चालना है differential equation है derivative करते हो, integration करते हो बस. If I ask you what is integration x, you say yes, x square by 2. But क्या है? What integration represent physically? If you understand, then you understood this. Otherwise, derivative represent the slope of the graph at any time, at any point. Derivative is tan theta, is theta. So velocity is nothing but slope of displacement curve. पूरी सांगितलं नाही का तुम्हाला? What derivative represent and what integration gives? Forget about mathematics. Let's go to mathematics. There is a curve. What integration gives you? Say integration y dx from a to b, from point A to point B. What it gives? I think now I should teach you M1, M2, M3, and then start dynamics. You are not learning M1, M2, M3 at all. If you don't know what integration gives, you are not learning element outside. What integration gives? And this was clear to us in 11th standard. Because while studying, मैं डॉक्टर खूब प्रश्न समझे ये ठीक है ठीक है तो क्वेश्चन करेंगे in 11th standard our teacher taught in the very first day determinant you were to determinant and value of the determinant is this multiplied by this minus this multiplied by this is the value of the determinant सारा चार पांच प्रॉब्लम हमें लेक्चर करेंगे टीचर से सेलेक्ट की करेंगे क्वेश्चन बस चार पांच लेक्चर झाल्यानंतर त्यांमध्ये वजन तुमचा विचार अभ्यासात त्याचं लक्ष नाही आहे प्रक्रियेचं वजन दिलेलं असतं Fortunately, my father taught me from first brother to certain standard. He know me very well, and he said, whatever are your doubts in your mind, try to find out answer yourself. Don't ask the person who is getting time out. I said, okay, good. And then I started thinking, this is a time and very in 11th and 12th standard, I used to read two books. Physics, mathematics, physics, I don't know whether you are referred. We had Gambhir and Vidya Prakash, still I remember in 1981. Okay, ते डिटर्मिनंटची व्हॅल्यू पाहतो काय करायचं पुढे त्यासाठी करायचं मेडिसिन ask yourself. Ask yourself. While studying, always ask. We make so many assumptions in structural engineering. You should ask, why this assumption? One assumption you make in theory of simple bending, plane section before bending remain plane after. Pattern. What is the use of that assumption? Why we are making that assumption? First question. The assumption का त्याचा उपयोग काय and when that assumption is not valid. मला साइटवरती काम करत असताना एखादी सिच्युएशन अशी येईल का where this assumption is not valid, and then what I should do? Can somebody tell me plane section before bending remain plane after bending? What is that assumption? Why we make it? When that assumption is not valid. असे अनेक प्रश्न माइंडमध्ये तुमच्या घ्यायला पाहिजे. Please try to find out answer yourself by doing some books. Then there is the point in taking structures to you. I think it's okay. These are my class and okay. Fine. Integration gives area under the curve. Is it? Area is equal to nothing. That's all. And derivative gives slope of the tangent to the curve at any point. These give our degrees. Yes, असं काहीतरी झालं होतं सर 11 झालं होतं सरांनी सांगितलं काय आठवत नाही. At least integration gives area under the curve is not clear. का माहित होतं? जिना माहित होतं. कन्फर्म होतं. Slope this is the derivative always gives slope of tangent to the curve at any point, and the derivative gives area under the curve. Okay. And now what was my question? Can you find velocity from this graph? Shall I take these discussions in between? आपलं ते चाललंय प्रॉब्लेम व्यवस्थित चालू दे, संपू दे प्रॉब्लेम. सेमिस्टर संपल्यानंतर मग बघू आपण हे सगळ्या गोष्टी. तुम्हाला वेळ मिळाला तर त्या मध्ये असे दोष वॅक्सिन घेऊ. कोविड वॅक्सिन चालू केला पाहिजे. डोस 1, 2, 3. So that will not face any corona afterwards. Structural corona. Okay. Well, at this point, if I want to find velocity, I have to find tangent to the curve. Now here, tangent to the curve is horizontal because it is P. Tangent to the curve is horizontal. At every extreme point, tangent to the curve is 0. And theta is 0. Theta is 0 because it is parallel to x-axis. And just check in real physical system whether it is valid. I have put the mass. It is at rest. Velocity is 0. It is passing through neutral position. Here, displacement is 0, but velocity is maximum. Velocity is maximum. And because of that maximum velocity is goes to the negative extreme. Yeah, negative extreme now. When the displacement is minus y0, velocity is 0. It stops for a while here. And then again starts backward journey. Velocity is maximum here. And then it comes to the initial position, velocity is 0. Match hota hai. Physical behavior of the structure and mathematical equations graph, they match the behavior of structure, the behavior of system. Yes. One more question. Here the velocity is negative. This is V. Here the velocity is positive. V. How do you decide positive and negative? For angle, to decide positive and negative direction of angle in structural engineering, always remember this is x, this is y. Always move from x to y, that is positive angle. Note down this sign convention. If you move from x to y, that direction is always taken as positive direction. Sometimes in beams, etc., we take this sign convention. This is positive x, we take this is positive y, etc. In beams, in that case, positive angle is moved from x to y. This is positive. Well, in this case, positive direction is anti-clockwise. This is clockwise slope, so it is negative velocity. This is positive slope, anti-clockwise, and so on. You can check. Now, my question to you, and that problem I'm going to give you for assignment. If I give both initial velocity as well as initial displacement, how the graph will be? Graph of displacement versus time. Correct plot. You are right. Plot it. Maybe you can remove, or on that graph itself you can draw dot it. No, displacement is there, y0. At t is equal to 0, y0 exists. So you can start that graph from that point where we started present graph. I'm giving velocity also. I'm giving velocity also. Velocity is not zero. Agree. So that point should be there. You can turn back and think that and plot on it. Slope of the graph and line should be positive. So, we are going to back and plot the graph. Listen. Again, positive velocity. We are getting the graph will start like this. It will go like that. And P is equal to 0, y is y0, no doubt. This slope will be V0. And because of that, the slope displacement will not be y0, it will be more than that. It will be more than that. If you don't agree mathematically, let us go physically. I have put the mass for y0. And now how you are giving initial velocity? By hammering it. Hammer it. It will go further, no? Then it will vibrate between those points. That's why maximum displacement will be more than y0 if you give in addition to y0 v0 also physically. Try to understand both physically, mathematically, then only you will realize what is the correlation between physical behavior and mathematical models. And then you have to check whether your mathematical model is correct. Anyway, displacement versus time graph we have plotted. Next, we have to plot the velocity versus time graph. If I take derivative of equation 4, I can get equation of velocity. Why not? To say taking derivative of equation 4. Derivative of equation 4. Y dot is equal to minus alpha by 0 sine equal to t. Let me call this equation 5. It is nice if I plot this graph properly. We do this graph by taking corresponding points. If there is no space on your notebook, you can plot this graph again, pull down these points so that you can understand correlation between displacement and velocity. In the present problem, I have given only initial displacement, no initial velocity. Remember that. And now equation 5 suggests the graph of velocity versus time is a sine curve plotted on negative side. So let's plot a sine curve on negative side. You do like this. At 0, sin theta is 0, velocity is 0. This is, you can say, velocity versus time graph. What is the maximum velocity? When sin theta is maximum. Maximum value of sin theta is 1. So maximum velocity is alpha into y0 is negative positive. The maximum value is alpha y0. This is also and so on. Agree? When displacement is maximum, velocity is 0. And where velocity is maximum, displacement is 0. You can check physically. Here I have put the mass directly in position. Displacement is maximum, velocity is 0. And when is mass to neutral position, displacement is 0, but velocity is maximum. Well, if I want to find equation of acceleration, taking derivative of equation 5 further. So derivative of sin alpha t is alpha cos alpha t. So minus alpha square with 0 cos theta. So again, acceleration versus time graph is cosine curve. The ordinate of 0 and it has to be plotted on the negative side. Acceleration versus time graph. Minus plus minus plus. T is equal to 0. Acceleration is alpha square.
initial displacement velocity
and initial velocity
initial
zero. And initial velocity v0. Also. Plot displacement versus time, velocity versus time, and acceleration versus time in hours. Big like camping. This problem is, I think, solved in Mario Pass. So for this subject, you can use, I think they have given you books in book bank. You can go to library and take book bank. So structural dynamics by Mario Pass is good book for beginners. Refer it. It is a short problem from there you can refer and understand and do it. But I have told you how the shape of the graph will be and what will be the maximum displacement. Right? Okay. What's time now? 120. 120. Let's continue for 10 minutes. So up till now we have discussed horizontal vibration. Now let us discuss if the system is vibrating vertically. How the governing differential equation is going to change. Okay, you can read that vertical vibrations. Of course, it is undamped free vibration. Same system. I'll put vertical. System is having mass and weight W. Stiffness of the spring is K. The only problem we face here, because of the weight, the spring will elongate by delta. And it will be at rest in this position. If I consider static case, it will elongate. Right? So, mention that. In vertical vibrations, due to weight of the system, the spring will have initial elongation delta. And if I use a simple equation, P is equal to K delta, simple stiffness equation. Delta will be P upon K. And that P is nothing but W. Delta is equal to W upon P. Agree? Now in vertical vibrations, you have to take the static equilibrium position as the neutral position. After static elongation, it will be at rest, it will be in equilibrium. That position you have to take as neutral position. So you can say for vertical vibrations, static equilibrium position is taken as neutral position. Now you can say you are given some initial displacement, the system is vibrating. Consider free body diagram of the system at some distance y from the neutral position. Rest of the procedure is same as that of horizontal vibration. Let us mark all the forces acting on this mass. First of all, the weight is acting downward, W. Then there will be elastic force in the spring, and that will be K into the total displacement, delta plus y. Right? Force in the spring, total elongation. And now the inertia force, if the system is vibrating, whatever down. So here in vertical vibration, one more force we have to consider, and that is weight of the system. Otherwise, elastic force and inertia force are same. They are there in horizontal vibration also. Weight of the system will come in the equation. That's the only difference. And now you can say applying D'Alembert's principle to the free body diagram. Applying D'Alembert's principle to the free body diagram. We get the body of the law plus K into delta plus y minus W is equal to 0. If I expand the bracket, the body of the law plus K delta plus K into y minus. What is W? Delta is equal to W upon K. Therefore, W is equal to K delta. I can write W is equal to K delta is equal to 0. This K delta will get cancelled. And thus I get the differential equation of vertical vibration as whatever dot plus Ky is equal to 0. Is it the same differential equation? So if you take static equilibrium position as the neutral position, you get the same differential equation, no change. So vertical vibrations and horizontal vibrations are similar. So you can say this differential equation is same as that of horizontal vibration. Also, therefore, it indicates vertical and horizontal vibrations are similar. Therefore, your solution will also be same. Y is equal to A cos omega t plus This one negative. Same solution. If equation is same, where omega will be under root k upon n, even for spherical coefficient. Stiffness of the system upon mass, root. Once you get omega, you can find period, you can find the frequency f, and so on. Okay, we'll stop here for today. Tomorrow I am available, so tomorrow I'll take at 12:15. Okay, Orchid is there, Gurgaon is there.
Yes.
Okay, Sapute is present online?
Yes.
No. So number 3 is absent. Then Zenith is there. Sushi.
Yes, sir.
Okay. Gore is there online?
Yes.
Okay. Wanjre. Okay. Mutapalli is there. Inamdar?
Yes.
No. Number 9. Sayyid?
Yes, sir.
No. Okay. Roll number 10. Pawar? Roll number 11. Who is roll number 12?
Bund.
No?
Bund Sanjay.
Bund. Who is roll number 13?
Sasne. Saurabh.
Sasne. Both are absent.
Yes.
So option numbers are 3, 9, 11, 12, 13.
Yes.
Okay, we'll stop. We need tomorrow at 12.